first example we're going to solve together is a motor start sequence. In this example, we have two discrete inputs, the start and the stop, and the program we are going to build is going to enable us to use these two inputs to control these three outputs: oil motor, main motor, and auxiliary motor, in a manner that's illustrated in these 5 requirements. So let's see these requirements one at a time. Requirement number 1, oil motor has to start once start, which is a normally open momentary switch, is pressed. Simple discrete input output requirement. Requirement number 2, once start is released, oil motor has to remain on. Again, we have done this requirement before. It's simply a latching requirement. Requirement number 3, 10 seconds after oil motor is on, main motor has to start. In other words, the only condition that will trigger the main motor to start is a time delay of a value of 10 seconds. Requirement number 4 is a similar requirement. It's a 5-second timer delay that's going to trigger or start the auxiliary motor. Finally, the requirement number 5, anytime the stop, which is a normally closed momentary switch, is pressed, any running motor of these motors, oil motor, main motor, or auxiliary motor, will be de-energized. In this example, we have a mixture of discrete IOs and timer requirements. So we have done discrete IOs before. We're going to follow the same logic we have done before. Now, regarding the timer requirements, there are 2 things that we need to consider before we start building our solution. Number 1 is the number of timers. Number 2 is the timer's type. So for the number of timers needed to solve this problem, simply we have to look at how many timer delay requirements that we have. In this example, we have 10 seconds delay, and then we have a 5-second delay. Now, what we are looking for in this requirement is simply a time unit. It could be seconds, minutes, hours, days, whatever, as long as it's a time unit at the end of the day. Now, since we have 2 timer delay requirements, this is an indicator that we need to use 2 timers to fulfill these timer requirements. Now, please remember, we are just starting with the timers. As we progress more, once we introduce the comparison instructions, this analysis will be different. We can actually implement the solution with simply 1 timer, but for the time being, since we have not covered the comparison instructions yet, we need 2 timers, 1 timer with a preset value of 10 seconds, other timer with a preset value of 5 seconds. The second concept is the types of the timers that we need to use. So we have covered 3 types of timers in Allen Bradley: TON, which is a non-retentive timer, TOF, which is off-delay timer, and an RTO, which is a retentive timer. The question is, which one of these timers is best suitable to implement the solution above? Now, remember, technically you can use any timer to fulfill any requirement. However, remember this, it's always depending on the requirement that you are building and the program that you want to achieve. It would be easier to go with one of these timers depending on the requirements. Now, as for this example, since we do not see any requirement that talks about retaining or maintaining the value of the accumulator after we hit the stop, it means the retentive timer should not be used over here. Could be, but there should be an easier way. Similarly, there is no other requirement that shows us if we want an output to remain on after stop is pressed. So the TOF is not the way to go over here. That's why it's easier to build the solution using timer on delay, the non-retentive timer. Now, what we will do, I'm going to demonstrate the solution step by step, how to use the TON to fulfill these 5 requirements. And at the end, I'm going to show you just a screenshot how can we different solution using RTO. So remember, it's your call at the end of the day to go with which timer. You can go with TON or RTO or even TOF. However, always it's easier to go with one of these timers depending on the requirement that you are solving. Let's go ahead and see how RS Logics works using a TON. The RS Logics implementation, step number 1 requires creating the tags. I have already, to save some time, I've created tags start, stop, and the 3 motors. As you can see, all of these are booleans. And since we agree that we are going to require 2 timers to implement the solution, that's T1, T2, and both these have data type as timers. Let's go ahead and start the first rung. So the first rung, we're going to have an XIC referring to start, and this is going to trigger an OTE for the first motor, which is the oil motor. And remember, there's start as a momentary switch, so we are going to require latching requirement, which is another XIC instruction referring to oil motor that's going to bypass the start once the start is released. That's my on section of this rung. We also need the only condition, which is the stop. That's an XIC referring to stop. I'm moving a little bit fast with these instructions because we have done them before. So we have done this example. Right now, the second requirement, it says, or third requirement in that problem, it says 10 seconds after oil motor is on, we need the main motor to start. In other words, together with the oil motor, we need to start a second, the timer. So the timer, we insert from the timers tab, insert TON because we agreed we are going to go with a non-retentive timer. The timer name is T1. The preset value in that requirement is 10 seconds, so 10,000 milliseconds. And the first rung is done right now. In the second rung, what we are going to do, we are going to make use of the done bit of the timer to start the main motor. So start, trigger the oil motor with the timer. 10 seconds later, the main motor will be on. But there is one more requirement, which is a 5 seconds delay after the main motor is on. So similar to the first rung, I'm going to create a branch parallel to the main motor. I'm going to have the timer 2. So timer 2, and this one will have a preset value of 5 seconds, and I can make it equal to 0. I like to use to copy and paste a lot, so Control C and V. And then the third, the last rung, we are going to have the timer 2 done bit. So I need to fix it over here. Please watch out when you're doing copy and pasting. You might just keep the same input on the pasted rungs. The done bit will trigger the last motor, which is the auxiliary motor. So that's our program right now. Start, stop are responsible to start and stop the oil motor and T1. After 10 seconds, both main motor and T2 is on, and after 5 seconds of main motor being on, the auxiliary will start. Let's download this program and see if this solution actually fulfills the requirement that we have to consider. So no errors, that's a good thing. Let's show right now the start is normally open. That's why you can see to the left side of the screen it's reading 0 into the PLC memory. You press that switch, it changes to 1. Even when you let go, the latching take care of the maintaining the path. So oil motor is on, timer is on for 10 seconds. 10 seconds later, the done bit is set, the main motor is on, second timer is on for 5 seconds. This guy is on, the auxiliary is 5 seconds after this one, and main motor is 10 seconds after oil motor. Anytime you decide to hit the stop, remember the stop is a normally closed switch. That's why to the left side of the screen, you see it's reading 1 into the PLC memory. You press that switch, it will be open. The XIC instruction, this one, changes to false. It breaks the rung, and literally everything goes to 0. One more time, you let go for the stop. Sorry, that's okay. It goes back to the closed state. XIC goes back to true. One more time, if you hit the start right now, in the middle of, right now it's still running. If you decide at that point that you want to hit the stop, it will stop everything right away. So that's the solution using TON. And right now I showed you how to build this one using the proper library tabs for all XICs, XIOs, and these timers. And I'm going to just to show you a screenshot of how can you build a similar solution for the same requirements using TON. And remember, at the end of the day, there is no one correct way in programming. There are infinite ways for your solutions. It all depends on your personal preference. Let's see how the RTO solution for this one.